working on this kind of full pipeline from idea to CAD, synthetic data, training, material strength, and control. This particular video, we're going to show a piece of this, which is once I have CAD, I want to actually just do a pass at control. So before we get to this full pipeline, we're skipping over the idea, over the CAD, and somewhere between the CAD and control, we want to gather data and then start to create code that we can execute and create kind of a functional environment to do training, a training loop, a training pass, generate synthetic data, etc. So that's the start. That's what we're going to focus on today. Let's say I wanted to create some control code for the RE speaker 6-DOF microphone. This is just one example of the various things that I'd like to create control code for. Maybe one of these. In this particular case, I'm gonna create some code for the Raspberry Pi. I can do the same thing, getting the code for ROS in Python or C or any of those kinds of things. And this is a simple example showing the basis for my work on whole body control using just CAD, or even at some point in the future, just an idea. The idea here is I've given this whole set of code to a set of models, a reasoning model, a coding agent, QA agent, etc. And those agents are then capable of creating the control code for anything that I design. So I'm using my normal standard vibe coding. So it's going through and fixing errors and those kinds of things for me. I'm not doing it on my own. So when I go to run this, let me just clear so it can just run pretty easily. When I go to run this, I'm going to basically decide, if I'm going to run headless or if I'm going to run with a simulator. We're not there yet, but what I'm going to do here is just say, I'm going to just get rid of that and replace that with this thing, this 6-degree microphone from ReSpeaker. What I expect to come out is actually control code. I can change a bunch of things. I can change whether I want it in Python, C++, if I want it in Go, Rust, you name it. And it'll try its best to spit out as much control code as possible. And so let's just watch it work, and then we can come back and talk about how it happened. So the first thing that happens, looks like I already have this one. That's interesting because no, it actually went through. Oh, I never hit save. That might help. So let's try it again, and we'll hit run. And let's make this more visible so you can see what's going on. So first thing that's going on is it is looking into, okay, where are the different repositories that this code might present itself? Like, what's all the documentation? What are all the, like, if there's a blueprint, if there's a circuit diagram, wiring diagram, any of those things, looking for all of that, a spec, design spec, operating parameters. It's going to try to find everything from the manufacturer first, and then it's going to fan out from the manufacturer over to community repos, looking for any documentation on this code. It's going to look for the operating at the edges, like what temperatures can it operate at, what's the lowest current that it can operate at, etc. What's the highest temperature it can operate at, lowest temperature, all those kinds of things. It's going to put those into an order that I can utilize later and basically create a parcelable data based on that. So what you see just happen is it actually created a node here and a service also as well for this microphone class. And I don't know exactly if this is going to work because I'm running on my Mac, and I can run ROS on my Mac. but setting that up, it's a little bit tedious, and I just wanted to show a quick example of what it does and not necessarily whether it works or not. I do check in virtual environments whether this code works. I did not spin up a virtual environment here because this is just the first video in this series about this. But basically here it is. It looked for the ReSpeaker 6 mic circular, and this is an extension board designed for Raspberry Pi. So it's getting this stuff straight from the internet using agentic behavior. It also has some understanding of what this might be used for in the context of robotics, and then goes through all the community resources it found, the number of stars, if available, of that resource. Like for instance, if it's a GitHub repo, and Seed Studio would not have a number of stars, but it will definitely have, here's an issues list, here's the star rating, etc. And we can go deeper into these, like does it compile, is it green from a build perspective, those kinds of things we can also add in here. For the moment, what we're doing is just collecting this data. And what this is for is, say I had a CAD file, or say I had even an idea of what a CAD file should be at some point in the future. Based on that CAD file, it's going to have parts that are fabricated. It's also going to have parts that are already manufactured, and we want the manufactured official documentation. We want to know if it's compatible with the system that we're building. So on top of this system, this is one part of a multi-part system. On top of this system is an understanding of the robot parameters we already have. So we're going to make sure that this code works with the code that we already have. And so when the virtual environment spun up, the first thing that happens is it says, okay, based on the code that I already have, the parameters I already have, like for instance, the Linux kernel or whatever it might be, or if there's some requirements about, say, drivers, NVIDIA typically has, those kinds of things, then we can say, all right, based on all these things, this is a good product fit, this is maybe not a good product fit, just on that alone. I think just that understanding is compiled into one place is worth making this into a company. But this is not a company on its own. I'm actually building out much more in the way of understanding these kinds of things, or having robots understand themselves. So we save this information in a database. We save all the GitHub source repos that we can find in the database. We're passing those to our coding agent, which goes off and uses this, and we're going to look into that in the next video. But it actually creates control code and tests itself. In this particular case, in Python, I didn't give it any of the variables that you could set, but it's just going to run Python by default. But I could say something like, give this to me in Go or C++, and it will go off and try to find that. And all of the resources that it can find. I just let it go off in an infinite loop, looking for all the existing resources that match my description. And that's good enough on its own. Like if I just had that would be great for the most cases. And knowing, especially if there's a star rating, that to me is highly useful just on its own. But now I have all of these repos. I have all of this potential test code. If they're like combined scores, I have all of that. And we can move on from there. I have drivers, if they're drivers, and an understanding of everything from the product itself. When I'm done with all that and it's giving me the final output, this is the same as you've been looking at before. It gives me recommendations as to what the particular source documentation that I should use, and I think it's fairly accurate now. I don't know if there's an Arduino package, and maybe someone created one, but from there, it creates a folder. This folder is all on its own for this particular component. And I don't have too many on my laptop, but on my hardcore coding machine, I have hundreds of parts that are now been defined like this, and with a node This one is not as an example because we haven't brought in the actual control, the coding loop into this. But this is the start here, where you're able to bring in your coding loops like you've seen me do in the past. Requirements file, README, all of that will start to fill itself out with the coding loop. So this is where we're going to end this one today, but you can see where this is going. I think this is something that we're going to see in our future more regularly, where someone decides they want to use a part, and now it's fully tested, because the next step after this, after you get the control code, is obviously to test this in any way possible in the simulator. You can create code to test even sound modules in simulators, and all of that will be created by this software. So thanks, and look forward to for more from me in this space.